In April 2029, an asteroid roughly the size of a cruise ship will pass extraordinarily close to Earth. It will not strike us. It will not destroy a city. It will not trigger an extinction event. But for a few hours, something remarkable will happen. A giant piece of rock from the early solar system will pass closer to Earth than many of the satellites we depend on every day. And millions, potentially billions, of people across parts of Europe, Africa, and Asia may be able to look into the night sky and actually watch it move. The asteroid is called Apophis. Its official designation is 99,942 Apophis, and its story is one of the most fascinating examples of how quickly our understanding of an asteroid can change when better observations arrive. When astronomers first discovered it in 2004, they had only a limited amount of information about its orbit. That was enough to create a serious question. Could this object eventually hit Earth? For a short period, the answer could not be ruled out. Early calculations produced an unusually high impact probability for the 2029 encounter. Apophis even reached level 4 on the Torino impact hazard scale, something no other asteroid had previously reached. That sounds terrifying. But there is an important detail. An asteroid's impact probability is not a permanent prediction. It changes as scientists collect more observations. And that is exactly what happened with Apophis. Astronomers searched older records and discovered additional observations of the asteroid from before its official discovery. Those extra measurements extended the period over which Apophis had been tracked. With a longer observational baseline, scientists could calculate its orbit much more accurately. The frightening possibilities began disappearing. The predicted impact probability dropped away. Later radar observations provided an even clearer picture of its trajectory. Today, scientists have ruled out an Earth impact from Apophis during the 2029 encounter, and current observations show no impact threat for at least the next century. So why are scientists still so interested? Because avoiding Earth is only the beginning of the story. On April 13, 2029, Apophis will pass approximately 32,000 kilometers above Earth's surface. That is incredibly close in astronomical terms. The Moon is roughly 384,000 kilometers away. Apophis will come to Earth at less than 1/10 of that distance. It will also pass inside the distance of geostationary satellites. That does not mean the asteroid is going to hit a satellite. It simply means the asteroid will travel through a region of space where some of our most important spacecraft normally operate. And because Apophis is so large and the encounter is so close, Earth's gravity will have a measurable influence on it. That is what makes this event scientifically extraordinary. Imagine holding a small object in your hand and moving it past a powerful magnet. The closer it gets, the stronger the influence becomes. Earth's gravity works in a similar way, except the interaction involves an entire asteroid moving through a planetary gravitational field. Different parts of the asteroid experience slightly different gravitational forces. Scientists call these tidal forces. On Earth, tidal forces help create the ocean tides. On an asteroid, they can potentially move loose material, disturb unstable slopes, alter the body's rotation, and reveal information about its internal structure. Scientists do not yet know exactly how dramatic those changes will be. And that uncertainty is precisely why Apophis is so valuable. For decades, researchers have studied this asteroid using telescopes and radar observations from Earth. Those observations have already revealed that Apophis is not simply an uninteresting ball of rock. Its physical properties, rotation, shape, and internal structure are all subjects of active scientific investigation. One of the biggest questions is what will happen to its motion when it passes through Earth's gravitational field. The asteroid is already rotating in a complicated way. Its orientation does not behave like a perfectly balanced object spinning around one simple axis. That makes predicting its exact response to the 2029 encounter more complicated. And this is where the story becomes something much bigger than an asteroid flyby. Scientists are preparing spacecraft to observe the event from close range. The European Space Agency is developing a mission called Ramses, short for Rapid Apophis Mission for Space Safety. The spacecraft is being designed specifically to rendezvous with Apophis before its close approach to Earth. The plan is extraordinary. Instead of arriving after the asteroid has passed Earth and simply photographing what remains, Ramses is intended to reach Apophis before the encounter. It can then accompany the asteroid as it approaches Earth. That means scientists can observe Apophis before Earth's gravity significantly changes it. Then they can watch what happens during the encounter. And afterward, they can compare the asteroid with its earlier state. It is essentially a natural experiment that nobody had to build. Nature has already created the experiment. Earth provides the gravitational force. Apophis provides the test subject. And the spacecraft provide the instruments. ESA says Ramses is intended to study Apophis's shape, surface, orbit, rotation and orientation before and during the flyby, while also helping researchers understand its interior structure and physical properties. The mission is currently moving through construction and testing with a planned launch in 2028. Japan's space agency, JAXA, is also contributing to the mission. This international cooperation matters because Apophis represents more than an interesting object in the sky. It is also a planetary defense opportunity. If humanity ever discovers an asteroid that really is on a collision course with Earth, knowing how these objects behave could make the difference between guessing and acting intelligently. We already know that asteroid deflection is possible in principle. NASA's DART mission demonstrated that a spacecraft can deliberately change an asteroid's motion. But before you can successfully deflect a dangerous asteroid, you need to understand what you are dealing with. Is it solid rock? Is it a loosely connected pile of fragments? Does it contain weak zones? How does its rotation work? How much force can its structure withstand? What happens when gravity pulls on it? Apophis gives scientists a rare chance to investigate some of those questions without an impact threat hanging over the planet. And there is another spacecraft involved. NASA's OSIRIS-REx spacecraft, which successfully returned samples from asteroid Bennu to Earth in 2023, was redirected toward Apophis after completing its original mission. It is now known as OSIRIS-APEX. Unlike Ramses, it will reach Apophis after the asteroid's close encounter with Earth. That timing is extremely useful. Ramses can provide the before and during perspective. OSIRIS-APEX can then investigate the asteroid afterward. Together, these observations could reveal changes that would otherwise be almost impossible to detect. Scientists may discover that loose material has shifted. They may detect changes in the asteroid's rotation. They may identify surface disturbances. They may learn more about its density and internal structure. Or they may discover that Apophis changes far less than some models predict. Either result is scientifically valuable. That is something often lost in dramatic space stories. A scientific prediction does not have to come true to be useful. Sometimes the most important discovery is finding out that a model was wrong. And Apophis gives researchers an opportunity to test those models against nature itself.